Today we're talking about arrays. We keep exploring that computer science concept. Let's get back to the slides. Okay, so highly recommend reading chapter number 6. Let's repeat what we did last time. Last time we were talking about copying arrays, right? And we said that you can't really just say array 2 is equal to array 1. In this case, you'll be just changing the memory references. You will not be copying the content of the arrays, okay? In order to copy content of the one array to another array, what you have to do is this. You need to have a source array, target array, right? So there will be like two arrays of the same size, okay? So this one has size of 5 elements. This guy has size of the same, right? Source array that length would also give you 5. For int I is equal to 0, I is less than array that length, I plus plus. Target array of I is equal to source array of I, which means that we're basically copying an element by an element, right? So we copy that, so that's like, we copy the content of the array, okay? Instead of using that, you can use Java API tools. There is a system.array copy function. That does exactly the same thing, but I guess like a bit easier maybe. So I personally prefer not to use that because, you know, there are different programming languages. There is Java, Python, C++. That exists only in Java. In other languages, it does not guarantee to be existing. That's why I personally don't like that. But you can definitely use it if you want to, right? So how do you do that? You say array copy or system array copy, right? Then you provide the name of the array you copying content from, then the position, source position, so you copying content from that position, okay, from that index. Target array, you provided the name of the array you copying content to, target position, so where you start inserting your elements, and the length, which is how many elements you're going to copy. For example, if you want to copy the entire source array to the target array, that's how we use it. You would say source array 0, target array 0, source array that length. Okay. Passing array to methods. So we said that when it comes to primitive data types, we pass in by value, right? But when it comes to more complex data types and arrays, we're passing by reference. Okay, so which means that you have a method, you pass in an array to another method. That method does something to that array, which actually changes the original array. So it's not passed by value, it's passed by reference now. Now, coming to new content, the variable length argument list. You can pass a variable number of arguments of the same type to methods. Okay, so here's how it works. Online GDB. So let's say you create another method. Public static, let's say void, no, let's say int add. Okay, so supposedly I want to add two integers and return the one which is the sum of two methods, sum of the two. Okay, so for example, I would say int a, int b, right? Put a comma there, and here I would say return a plus b. Okay. Perfect. Okay. Yeah. So in this case, what would that mean? That would be sum is equal to. So what if I try to call this method on, let's say, 10 and 15, right? Sum is equal to, add 10 and 15. 10 will be passed as A, 15 will be passed as B, A plus B is 25, return it back to the sum, it will be 25, right? So we should see something like sum is equal to 25 in our console. Perfect, okay. Now the question is, what if I want to create a method which would have, let's say, not 2 integers, but 3. So it would do exactly the same thing, it would just accumulate the integers, but let's say 3 instead of 2, okay. What I'll probably have to do is take advantage of method overloading, right? So I would say int c, okay? And then here I would say a plus b plus c. By the way, this is equivalent to saying like int return is equal to a plus b plus c, okay? And return red, okay? So you can do that as well. It's just shorter. What I'm doing here is shorter. Okay. It calculates it right there and then immediately returns it back to the method, to the main method. Okay, and then next question is, what if I want to add 4 numbers instead of 3? What would I have to do? I would probably have to, again, do the method overloading. I would do something like this in D. Okay. Return a plus b plus c plus d, and that can actually go forever, right? So like nobody knows how many variables I want to pass. Okay, and that's kind of inconvenient. In order to avoid that, there is actually a way, and that's what we're talking about in this lecture. We can create a method like this add, for example, which would accept any number of integers. Okay, so are you providing 2? That's fine, we'll take that. Are you providing 4? That's fine, we'll take that. Are you providing like 20, 100, 1000 integers like in the add? That's totally cool. You'll take care of that. Yeah, and that's how it works. So basically, in the parameter list, right, in the parentheses, you need to specify the type name. In our case, it's int, and then you need to put dot dot dot, and then parameter name. Okay, in the method declaration, you specify the type followed by an ellipsis. Okay, so those dot dot dot. Only one variable length parameter may be specified. That's like a limitation, right? So if you do that thing, just do it only once. And this parameter must be the last parameter. Any regular parameters must precede it. In other words, here's what we have. What you can do, if you want to accept any number of integers, what you can do is this. You specify the type, as you normally would, right? Then you would, I don't know, put the name. And then what you have to do is put dot 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 here. In this case, that is a sign to a compiler, like, look, like this method accepts any number of integers. Any number of integers. Okay. Any number of integers. Any number of integers, yeah. So return 0. Okay. So let's see if that works. Perfect. Sum is equal to 0. Okay, so we do not see any mistakes, any errors. Okay, that's good. The method add is being called. 10 and 15 are being passed, right? So this method is being called. There are no errors, no compilation errors. Everything worked fine. And here I'm just returning 0. That's why we see sum is equal to 0, right? I'm not doing anything with these two numbers. Okay. Well, okay. Yeah. Now, the next question is, how do I take advantage of it? How do I extract like 10 and 15? Like, what specifically should I do such that I will add those, let's say, those 10 and 15? The way it works is this. Inside the method add, that a or any parameter which is supposedly like any number of integers, right, that becomes an array. So the way it works is that instead of one variable, a, that becomes an array, which means that the way I process it, so let's say I'll call it array, becomes exactly the same way you will process any other array. So for example, how would I find the sum of all the elements in the array? I would create a for loop. Again, always use a for loop when you're processing an array. I is less than array.length, I plus plus. Okay, so int sum is equal to 0. Sum plus equals array of I. Okay, and then return sum. Yep, yeah, that should be good. Cool, 25, yeah, awesome, yeah. So basically this this array, this variable, this parameter, or whatever I call it, I can keep calling it a, right? That becomes an array, and that functions exactly the same way an array would. Yeah. Now again, keep in mind that there are a couple of restrictions. Okay. So the first restriction is only one variable length parameter may be specified. So there is a restriction such that if you're doing like that extravagant way, right, of accepting any number of parameters, then you need to limit this to only one instance. In other words, you cannot create something like this. Okay, and the question why, right? So why there is a restriction like that? There is a restriction because Java will not be able to understand, like if it sees list of arguments, where does the first one finish and where does the second one start. it will not be able to understand like where's the border. That's why if you do that kind of stuff, you need to do it only once. That's one restriction. Second restriction is this: that variable argument list, it has to come at the end of the parentheses, at the end of the argument list. So you cannot create something like this. You cannot create that. Why? Because again, it's not, well, I'm not sure why. Hold on. Not sure. Hold on, I forgot. But anyway, so it's not possible. It's not possible to do that. That in .a should always come at the end. Yeah, it should always be like that. I think I forgot what it was. It was something also with the borders, like how to distinguish the borders. I think that if it comes at the beginning, yeah, don't worry about it. Anyway, so it should always come at the end. Okay, so something like this is possible, right? Double B int A, or even int B int A. That means that when the Java sees the argument list, the first integer will become B, and all the rest integers will become A. Okay. What else? What else do you need to know? So something like this is also possible if you create an array with a size of 0. You see sum is equal to 0. So technically you're thinking, okay, so I'm accepting an array of integers. That is true, and the way Java works is that it's actually allow you to have an array of no integers. Well, an array of integers with a size of 0. So basically, you see, we're not passing any arguments, we're not passing any numbers, right? This method still accepts it, okay? And that A becomes empty. In this case, size of A is equal to 0. In this case, this doesn't do anything at all, right? And sum is still 0. Sum being 0 is being returned back over here, and that's why sum is 0. That's the idea. So that is also allowed. Now, for example, if you have 10, 15, that works as expected. Right now, if I add 10 more, so now it's 35, right? If I add 20 more, that would also work. So you see, it accepts all of them. Okay. Now, the question to you though. Question to you. So, what do you think? I'm not going to answer the question, so I want you to test it out and figure it out on your own. What do you think is going to happen if I have a code like this? Yeah. So what do you think is going to happen if I basically have two methods, method overloading? One of them accepts the number, one of them accepts only one integer. The other one accepts any number of integers, including 0 integers. Okay, so what do you think is going to happen? Is it going to call this one or that one? Let's say I'll multiply it, I'll add 10 here. Yeah. So for example, if I call add on 10 like this, so what do you think is going to happen? Is it going to call this method? Or it's going to call that method? So that'll be my question to you. Anyway, yeah, so any number of them is possible, right? So it will all be accepted, including 0, right? Including none of them, including empty parentheses. So that's 70, okay? And if I don't have anything here at all, then it will also work. Cool. Yeah. Hope it makes sense. I want you to do this exercise, and keep in mind that starting from the next week, I want you to submit all the notes which you've taken while watching this lecture. Searching an array. Okay, so let's imagine that we have an array of elements. So let's say, let's bring this color red. Okay. So imagine we have an array like this, right? Okay. And imagine we have some numbers. And the idea is that, let's say, for example, like similar to here, let's say we have a number, I don't know, 10. Okay, and we're trying to understand if 10 exists in our array. Okay, so that's a very, very popular problem of searching an element, searching for an element, searching an element in the array. Okay, so let's say there are, I don't know, multiple numbers, I don't know, 0, 1, 2, 3, 4, 5, and 10 in the middle. Okay, and in this particular case, I only have very few elements. 1, 2, 3, 4, 5, 6, 7. Only 7 elements in the array. Okay, and to you, it's clear immediately that 10 exists there. However, the machine, well, first off, you would never create a problem like that. You will never be searching for an element in the array of 7 elements only because it's too small, right? So maybe in class, maybe in college, maybe in this particular course, you will. But in real life, when there's a software developer, you'll have an array with 1,000, 1 million, 1 billion, 1 trillion elements. Okay, so like a human eye will never be able to like quickly figure it out if the element exists there. Also keep in mind that it is a machine, it is a computer. It cannot look at many elements at the same time. It can only take a look at one element at a time. That's it, right? So the question becomes, so what happens here? Like what kind of algorithm, how would you even approach that question? So how would you search for an element in the array and then return the position of that element if it exists? So for example, in our case, so 10 exists, right? Let's say I'm searching for 10. So that's let me change the color to green. Okay, so that's the one I'm looking for, right? It exists. It's located at the 0, 1, 2, 3, 4, fourth position. So our task, our assignment is to write a method, is to write an algorithm, which would search for a number in the array, return the position, in our case it's 4, if that element exists in the array, and return -1 in case if that element doesn't exist, because -1 is a position doesn't exist, right? So there is no -1 position. In Python, actually, there is, but not in Java. Okay. Yeah. So so how would you do that? The most intuitive way of solving the problem is to basically go through using the for loop, go through entire array, comparing each element of the array to the element you're looking for, to the key, okay? And then, for example, you're looking for 10, right? You compare 10 to 0. Is 10 equal to 0? No. Okay, move on. Is 1 equal to 0? No. Is 1 equal to 10? No. Move on. Is 2 equal to 10? No. Move on. Is 3 equal to 10? No. Move on. Is 10 equal to 10? Yes. Cool, and you return. What do you return? You return 4, which is the position. So how is that implemented? It's done. So that is called linear search. Linear search. Why is it called linear search? Because it's just like linearly you go from left end of the array to the right end of the array. You just like consecutively comparing your key. The element you're looking for is usually called a key, technical term. You're comparing your key to the element of the array you're currently looking at, right? For example, at the very beginning, when I is equal to 0, I'm looking at 0. Is 0 equal to 10? No, move on. So we're changing I, look kind of moving, shifting the playhead, like moving one position to the right. Is 1 equal to 10? No, move on, and so on. Okay. So that's the code. So here's the code for it. Here's the code. So again, like anything else, we use for loop. For int is equal to 0, int I is equal to 0, I is less than length, I plus plus. If key, so which is this, right? So if key, the element we're looking for, if the key is equal to list of I, so I is constantly changing, always changing, right? So if, let's say, when I is equal to, I don't know, 3, right? At that moment, we're looking at this position. So we're looking at this element. Okay, so list of I is equal to 3. When I is equal to 3, list of I is equal to 3. And at that moment, we're comparing a list of I, which is 3, to 10, to our key. If they're equal to each other, which means if key is equal to list of I, then we return I. Okay. If it's not, then if statement is being skipped, right? Java comes back to the for loop, increments I, and it just keeps doing what it's doing. So increments I, then comes back over here and again compares list of I has changed, right, to the key. If they're equal to each other, then it returns 1. If they're not equal to each other, then it skips it. So it skips the if statement, then comes back over here. Okay. Now, what's very, very important to understand, is the function of this -1, return -1, how that works exactly. So that's something which can be tricky, and that's something which you definitely should pay attention to. So, okay, so you probably got this part, right? So, like, okay, that makes sense. Once I find that coincidence, once I find that key is equal to list of I return I. That's cool. But how do you return -1? Okay, so -1 is returned where? It's only returned over here, okay? And the question is, when is this code, when is that line reached? There is only one condition when that line can be reached. The idea is this: if key is ever becomes equal to list of I, then return I. What does it do? That statement return I completely terminates kind of the break. It completely terminates the whole function, the whole method, right? And linear search returns the position. So this code is not reached in that case. Again, so if key is ever equal to list of I, then the function returns I, and this code is never reached. However, the only way return -1 can be reached if this is never true, if the key is never equal to list of I. So, in other words, you search through the entire array, you always compare its key to the list of I, and it was never true. Never. And in that case, this for loop terminates. Okay, so that was never true. The for loop terminates. Everything is good, and then it comes to this statement. And at that moment, so if you search throughout the entire array and you never returned, you're basically sure that your element was not found there, and that means you can return -1. Hope it makes sense. Moving on. Yeah, so definitely practice with this. Now, search an array. So that's called a linear search. Okay. And now we'll come to something which is actually even more interesting, and it's something which we're talking about in later courses. But okay, let me delete this. Okay, so imagine a situation when you have huge array, let's say there is like 1 billion elements, and you're looking for an element called 10. Element 10, okay? And imagine that you don't have any duplicates in that array, right? So you don't have any of them, like none of them are 10, apart from the very last one, okay? And let's say again, there are like billion of them. So, no, sorry. So let's say, yeah, okay. And let's say there's like 1 billion of them, 1 billion of elements, okay? The very last one is 10. Now, so what's going to happen is that if you're looking for 10, how long will it take you to find that 10 if, let's say, each comparison, so when you're comparing key to the list of I, if, let's say, that takes a second. Of course, it's not going to take a second. It's going to take like a fraction of a second. It's probably like 1 cycle or 2 cycles. It'll be very, very quick. But let's imagine it takes like 1 second. In this case, it's going to take 1 billion of seconds to do that, because your 10 is located over here, and you definitely know that you are starting linear search from the left, and then you're comparing your key to each one of those elements, going from left to right, changing the index like 1 by 1, kind of like shifting the playhead, right? And that's a problem. That's a problem because it's going to take 1 billion of seconds. That's too long. That's too much. That's not acceptable. In other words, if I have an array of n elements, so if I have an array of n elements, let's say big N, when n is any arbitrary integer, then it will take n comparisons to find the key, or to be sure that the key does not exist in the array. Okay, that's the idea. So in other words, that's too long. That's unacceptably long. That's why there is the question always comes in, and that's actually what we'll be learning in my 318 class. How can we make it quicker? That's very inefficient. We have to wait for like too long. How can we make it quicker? So there is a way to make it quick. So here's how it works. If we make sure that this array is already sorted, which means that all the elements are in non-decreasing order, or like non-increasing order. So like if you sort it in an increasing order, that means the elements, as you go from left to right, those elements, the values of those elements always increase. So for example, 0, 20, 30, 40, 100, 120, 50, 500, okay, 750, something like this. So you see the elements are always increasing as you go from left to right. You cannot have, for example, something like 10, because in this case, kind of they increase in here, and now like this element is out of order. It's less than 750. So that's why it will not be. It's not like yeah. So this should never happen in the sorted array. Okay. Again, so let's imagine that we have an array which is already sorted. And let's say 800, 1000, 1200, and then like 1300. Okay. And let's imagine that we're looking for our key is equal to 30. Okay. Imagine that our key is 30, and our key is obviously here. Right here it is, 30, and that's what we need to find. Or let's say our key is 1300. Let's imagine that our key is 1300. Okay, cool, perfect. Now, how do we do that? So if we know that the array is sorted, okay, then instead of linear search, we can do something which is called binary search. So binary means like two options, either left or right in our case. So binary, like in general, binary means you have something like related with two, right? I think the etymology of the word binary is like two options, two ways, okay? So here's how it works, the binary search. You basically comparing your key, 1300, the one you're looking for, right? But you don't really know that it exists there at all. You compare that to the element which is right in the middle of the array. So you're comparing this to this guy, 750. Let's say 750 is in the middle, okay? If 1300, if the element you're looking for is greater than 750, that means what? That means all the elements on the left, since they are even less than 750, they will definitely not be 1300. So in other words, if 1300 exists in that array, it's definitely not going to be on the left, it's going to be on the right. Okay, so that's how you eliminate half of the comparisons. You just trash it. You're basically saying, hey, like that half of the elements, screw them. We're not gonna watch it there. Okay, and then you have what kind of array are you left with? With this only 4 elements, which is approximately half of the size of the original array. Okay, so you see how quick that is. Now you have, like, let's say only 4 elements. What do? You find the middle one. In this case, I don't know, let's say this 1200, right? You compare your 1300 to this 1200, you see that 1300 is greater. That means it should be somewhere on the right from 1300 as well. So like you cross that out, you don't care about that, and then you just as well as 750 here, as well as 1200, right? Because you compared that already. So now if 1300 exists, it has to be on the right from 1200, and then you just you basically and then you look at 1300, and that's the one you found. That's the one you're looking for. You found it. You return like the position of it. That's the idea. So that's called the binary search. Again, every time. What you do is compare your key to the element in the middle, and then you decide if you need to go to the left or to the right. Okay, so there is a code to do that, and there is like very some explanation how to do that, and there is a code. Okay, yeah. I think I'll include some tutorials on this, but I definitely please study them on your own, and I'll see you guys in the next lecture.